Get ready to witness the future of electric vehicle technology. Tesla's latest innovation is about to change the game by introducing a more affordable and eco-friendly permanent magnet drive unit without any rare earth elements. While the Cybertruck and Model 2 remain a mystery, we've got exciting news to share about Tesla's next-generation electric motor and vehicle platform. In this video, you'll discover how Tesla plans to revolutionize the industry with its groundbreaking technology. Don't miss out on this electrifying discussion. Tesla's powertrain engineers optimized the price, weight, and size of the electric motor through quick iterative design by simulating the interaction between the magnetic fields between the stator and rotor using proprietary software. They also worked closely with Tesla's manufacturing engineers to achieve similar modifications to the manufacturing process and materials. According to Tesla, the production of the next-generation powertrain will require 75% less silicon carbide without sacrificing performance or economy. Tesla claims that despite the new drive unit's permanent magnet construction, no rare earth elements will be needed. It will be more cost-effective to construct, taking up 50% less manufacturing floor space than the motor in the Model Y and around $1,000 less per unit, which is significant given that the cars based on this platform are anticipated to be the most reasonably priced Tesla EVs yet. Any battery chemistry will work with the new platform, which will also use new production techniques to speed up production. Tesla claims that its decision to rethink the traditional series assembly line was motivated by lessons it learned the hard way while developing the frequently delayed Cybertruck. The new model's sides, doors, floor, and front and rear subframes will be built on separate parallel lines, coming together at the end of the line instead of the vehicle's unibody chassis traveling down the line as a whole. According to Tesla, this unboxed process is more effective, economical, and less prone to production bottlenecks. That final sentence is particularly crucial if Tesla is to meet its target of producing 20 million EVs annually by 2030. In addition to revamping and streamlining the wire harnesses that act as the vehicle's nervous system, the manufacturer is also reworking the low-voltage power system. It is switching from a 12-volt to a 48-volt design, which will allow for thinner wires, smaller components, and smaller heatsinks according to Ohm's law, all of which will assist in reducing weight. Next, Tesla is switching from a complicated network of analog harnesses to a network of smaller controllers designed and made in-house and connected to the vehicle's potent central brain by Ethernet. Bidirectional communication will drastically minimize the number of wires that wind around the body and make diagnostics and troubleshooting easier. On a schedule for the anticipated rollout of the upcoming platform, powertrain, or the car that would eventually host it, neither Musk nor other Tesla leadership who gave presentations during the Investor Day made any comments. By the end of 2024, Tesla has committed to providing at least 3,500 charging stations for all electric vehicles. In the US, non-Tesla electric vehicles can refuel at Tesla supercharger locations. Drivers in California, Texas, New York, and other states have utilized the adapters effectively since Tesla revealed on February 28th that certain stations had been supplied with them. In February, the White House issued instructions requiring EV manufacturers who wanted to receive federal subsidies to make their chargers brand agnostic. In the same month, Tesla planned to provide other vehicles access to at least 3,500 superchargers. A $1.2 trillion infrastructure law set aside $7.5 billion in 2021 to build a network of 500,000 public EV chargers by 2030, mainly on highways with heavy traffic and in residential areas with many people living there. One of the businesses contributing to the project's funding, which combines private financing and government grants, is Tesla. Although the firm hasn't disclosed where or how many superchargers are now accessible to EVs other than Tesla, you may use the Tesla app to search any location for suitable stations. By the end of 2024, Tesla has committed to opening at least 3,500 stations and 4,000 Level 2 charging stations to all electric vehicles. Tesla has refitted certain stations with a Magic Dock, a CCS1 adapter placed on top of Tesla's NACS socket that enables non-Tesla EVs to charge at a maximum rate of 250 kilowatts. Tesla said its upcoming PMSM traction motors would not feature rare earth permanent magnets at its 2023 Investor Day on March 1st. As stated by Colin Campbell, VP of Powertrain Engineering at Tesla, as the globe transitions to clean energy, demand for rare earths is increasing substantially. And not only is it going to be a little challenging to meet that need, but mining that rare earth, it has environmental and health implications. Although it wasn't mentioned on Investor Day, ferrite is the most likely replacement for neodymium batteries in Tesla's next-generation motor design because it's a tried-and-true idea. A ferrite-driven PMSM and a neodymium battery-powered PMSM were included in General Motors' second-generation Voltec powertrain found in the 2016 Chevy Volt. The performance of a neodymium battery-powered alternative can be matched or even surpassed by a ferrite-powered PMSM across one or more parameters. Still, this performance comes with a substantial weight or efficiency cost that has historically made a move undesirable. Proterial, for instance, simulated an electric vehicle traction motor using ferrite magnets that match the output and maximum rotation speed of a comparable PMSM incorporating neodymium battery magnets, but were 30% heavier, a huge weight penalty. In its second design, Proterial simulated an electrical vehicle, or EV, traction motor using ferrite magnets that match the output and motor weight of an equivalent PMSM made of neodymium battery magnets, but rotated at a 50% faster rate, resulting in a materially lower torque. A decade ago, the rare earth business was adequately referred to as the paradoxical stepchild of electromobility and clean energy due to the Bayanobo mine in China, the country's iconic clay mines, and those of neighboring Myanmar. There are now more supply options available than simply China, Myanmar, and other countries that are about to begin production. These options are transparent, near to home for Tesla in particular, and significantly less environmentally damaging than the Chinese manufacturers of the past. There aren't many current assessments of the life cycle impacts of rare earth production or comparisons of rare earth production from various sources, but what is known suggests that the environmental and health effects of rare earth production outside of China are, or have the potential to be, much smaller than those in China. The fact that the result presumes that the neodymium battery originates from China's supply chain, whose environmental and health implications are significantly higher than those of present and emerging alternatives, makes it all the more poignant. In 2022, Adamas Intelligence research revealed that passenger EV traction motors were responsible for 12% of global neodymium battery magnet use. With Tesla accounting for 15 to 20% of this 12%, its contribution to the world's demand for neodymium battery magnets was merely 2 to 3%. Therefore, if Tesla's idea is quickly developed and put into production, and if those motors are used in its entire line of vehicles, the global neodymium battery market stands to lose only 2 to 3% of demand in the short term and at most 3 to 4% over a long time, assuming Tesla maintains its leadership in the EV market. The overstated media and market response to the news reflects a general misunderstanding of supply and demand dynamics in the neodymium battery market. Adamas predicts that by 2035, the demand for neodymium battery magnets will have tripled, but production will only have increased by a factor of 2 due to the long lead times required to bring additional rare earth oxide manufacturing online. Given the anticipated supply shortfall, a 3% to 4% decline in demand by 2035 is hardly recognized. As you can see, this innovation is set to revolutionize the automotive industry and pave the way for a more sustainable future. But the excitement doesn't stop there. In this video, we'll be taking a closer look at Tesla's Giga Berlin, where the company is set to produce their electric vehicles on a massive scale. You won't want to miss it. If you found the video enjoyable, please don't forget to hit the like button before leaving.